There's an extremely short retention time in an interceptor. Although the plumbing code says 30 seconds, really a peak flow, it's 210 seconds. 3.5 minutes is all you got in there at peak flow. It doesn't happen too often, but when you look at a restaurant and how they run restaurants, they got weddings, they run all the dishwashers at once, you will get there. You will get there a lot more often than people think. We've done like 6-year studies at the Montage Resort in Laguna Beach and really looked at the dynamics of an interceptor when we developed the system. And there's some very interesting data, what's really going on in a commercial kitchen. The next thing that you're going to have is microbes alone are unreliable. We actually manufacture our own microbes in Missouri. We're one of less than a dozen of companies in that area that even manufacture it, that really make microbes. When you make microbes, you have to put them asleep. You have to give them a shelf life. That means like there's several technologies, including pH, where you basically make them sleepy, nappy, they fall asleep. Now you got shelf life. They take 5 to 6 hours to wake up. So if you go and you just add microbes into an interceptor into the drain, then you do the proverbial pouring money down the drain, because they're not going to wake up in a half an hour or 210 seconds retention time. They're going to wake up somewhere down in the sewer system. So we knew that. There's odor issues. That's always what the consumer has. The customer has big odor issues. He says he doesn't. That's usually what affects the customer the most, the odors, because that's unpleasant. There's sewer loading, bypassing. These interceptors, if they aren't really maintained properly, they simply bypass a lot of grease. Any sewer district can tell you that they find it. So they really don't work all that well. So we decided, as I said before, to take a bioreactor system, a fixed bed bioreactor, and really bring it in a $5,000 to $10,000 price range. So what we did is we relied heavily on electronics. A bioremediation process is a simple process, but you got to repeat it, and it has to be reliable. And as soon as it stops repeating itself, you got to know about it. Because if you let it go, then that grease trap fills up, and then you have a real problem. We also knew we couldn't use any moving parts. A grease interceptor, stainless steel alone, 6 months, it's gone. There's ABS, PVC, and nylon is the only things you can stick in an interceptor that make it. Anything else is gone. So we knew we had to come up with a very cost-effective solution. So we really got this GRS Bio Element that we received the patent on as well. Basically, it's a very simple system, and the next slide will show how we deploy it, but the water level of the grease trap is about here. So this thing sits on the ground. We inject air into it, and the air, of course, rises due to the Venturi effect, or just think of it as a chimney, basically. That the air rises up. These green things are the bioelements where we actually grow the microbes. Because the air rises up, and the next slide will show that a little bit better, is we're taking actually the liquid in here and we're expelling it on the top. So we're starting to recirculating this like an airlift pump a little bit. And we're using the air for two things at once. We're using the air to move the liquid throughout the bioelements. It's a very controlled aeration. And the second one is, of course, we supply the oxygen for the bioremediation process and the aerobic process. The orange line is basically where we inject the microbes. It's a very simple element. There's not much to it. And it has to be simple because it sits in a very difficult environment. It has to be easily replaced. There are absolutely no moving parts to it. There's really no clogging. We found out they're about 3 inches in diameter. By the way, this whole thing is about 10 inches in diameter. It is, in essence, a modified 10-inch PVC pipe, but we put a lot of stuff in it. Oops, black. Okay, sorry. Then it's easy to service and replace. As I said, it's fairly inexpensive, so you can just pull it out, put the new one in if there's any problems with it. It does not interfere with the gravity separation, which means it does not mess with the initial function of a grease interceptor. And we studied that, and we actually just had our IAPMO testing done about 2 months ago, where we had to write all our new protocols, because even IAPMO has never done that, and nobody's ever done that, and there's a new standard that just came out. So we've done a lot of pioneering work in this whole field. There is no pass-through, so no grease gets passed through, and it disrupts the channeling effect, and I show that in the next slide. That's basically when the water flows straight from the inlet to the outlet. It goes straight through, and really this whole separation of grease doesn't even occur. So what you have in a regular grease interceptor typically is you have the grease on top, and then you get the water underneath it. So if it's a third full or 25% full, Typically, city ordinances tell you pump it. Sorry. So what we do next is we put our bio elements in it, typically one per chamber, and when we start firing these elements up, the grease is still at the bottom, and so we start circling them through and start bringing it up to the top and bioremediate them. So that at the end, you still have a little bit of grease on the top. We do that actually on purpose because it keeps the odor in and it makes sure that you have a microbial culture and you have a food source, because the grease is the food source. What we have in them, we actually have live cameras. So we can actually dial up each of our systems. We can look at a live feed of it, see how it's doing. The cameras use UV LEDs that are pulsing, and since grease glows in UV, actually the computer, it's all computer controlled, can measure how much grease is actually in there. So if you have a wedding, the computer will actually inject more microbes. The computer injects it every 12 hours, so we make a new batch of microbes every 12 hours, just in case they make a mistake in the kitchen, which they do frequently. So once the system is running, you basically have your grease there, you have a little bit of residual grease, a 1 or 2 inch layer, and then this is how it will be without. So we're using a compressor. It's really actually a modified koi pump. So you're only drawing about 150 watts of power, and we have an inoculator. It's a 2-tank inoculator, which we have patents on it as well, which basically we take a concentrate, we transfer it every 12 hours, we inoculate it for 8 hours, and then we inject it into the interceptor. So this is actually a live feed where you can see, it's a food plant in Los Angeles where you can see over the next 2 months how this bioremediation looks like. We basically have these elements here. These time-lapse movies we actually generate for each of our customers. And we take basically a picture every 15 minutes. This is actually a little bit modified there. It's every hour. But we take every 15 minutes a picture. And if there's any issues with it, we can go actually back and we can sit down with the customer and say, you know, your cleaning crew did this, or you had a problem that occurred then. And so we can actually make him really aware of the interceptor as well. Because, you know, a lot of our customers, they don't even know about it, and they have no idea about the interceptor. They don't know how to maintain it proper. So this gives them also a really good tool to make sure everything is fine, and it gives us a great monitoring tool. There's actually physically somebody twice a day that looks at them and sees if they're all fine. So as you can see, there's searches and all of it in it. So this is an extremely helpful tool. The technology is extremely cheap by now. It's basically a webcam, so it's not much to it. These are some of the larger systems that we have at the montage. You can see here actually some of the live feed, and here we have a touch screen. This is one of our prototypes. The whole controller, we have now custom controller that was designed, and it's basically the size of a pack of a cigarette, and it has its own web server in it, and you can go look at any of the live feeds.